Okay, so now we're going to simplify expressions with rational exponents. So, to review, before we start doing this, I want to review a little bit of exponent rules. So, over here onto the side, we're going to rewrite exponent rules. So if I'm multiplying two numbers that are the same base with different exponents, I add the exponents. Okay. If I'm dividing two numbers that are the same base with different exponents, I subtract the exponents. Okay? And then if I have a number raised to an exponent and I raise it to another exponent, I multiply those exponents. Okay, so those are the exponent rules we're going to follow when we're simplifying expressions with rational exponents. Okay, so here's our steps. Rewrite all radicals in exponential form. You want exponential form, not radical form. Use the exponent rules, these guys, to simplify the expression. Write your answer as a radical in simplest form. So we're going to start in exponential and end in radical. Okay, I'm going to do all the odds. I know there's a lot, but we'll get through it. There's 1, 2, 3, 4, 5, 6, 7, 8. Okay, here we go. Zoom in a little bit. There we go. So, since I have two numbers that are the same base with exponents, I'm going to use my exponent rules over here, and I'm going to add the exponents together. So since they're both x, we have x to the 1/3 plus 4/3. Okay, when I'm adding fractions, they have to have the same denominator, and these do, so that's nice. So I get x to the 5/3. Okay, so now I'm going to rewrite this in radical form, just like we learned before. So x is my radicand. Actually, I'm going to start this over here because we're going to end up simplifying it. My index is 3. And I'm raising x to the 5th power. Okay. I can take out one group of 3 x's, since 3 goes into 5 one time, with 2 x's left over. Okay. So that's number 19. Number 21, this time we're using this exponent rule. We are going to subtract the exponents. But you may notice something. These fractions don't have common denominator. So I have to make one. So the common denominator between 2 and 4 is 4. So I have to multiply both of these by 2. So really, I have m, to the 10 over 4 minus 7 over 4, which leaves me with m to the 3 over 4, but I have to rewrite it in radical form. So I have m, my index is 4, my exponent is 3. And that's our final answer. Okay. All right. This time, I'm multiplying exponents because that's this rule right here. So, I have 32 to the 1/2 times 1/2, which equals 32. 1/2 times 1/2 is 1/4. Okay. So I'm going to rewrite that as a radical. It's asking me for the 4th root of 32. And I'm going to simplify that. 2 times 16. 16 is a perfect 4th. This is 2 to the 4th. Okay. So that means I can take out 1, 2 and put it out front with 1, 2 left over. And that's our final answer right there. Okay. You may remember, maybe I'll write this exponent rule up here too. If I have x to a negative exponent, that exponent flips the number over, makes it the reciprocal. So this is 100 to the negative 1/2 power. That negative flips this over, so it's 1 over 100 to the 1/2 power. Okay? 1/2 power means, if I rewrite this as a radical, my index is 2. I don't really need to write it, but I'll write it anyway. And this is 100 to the 1 power, so I don't change it. So this is asking me 1 over the square root of 100. Well, what's the square root of 100? 10. So that's our final answer, 1 over 10. In number 27, we have another negative exponent. So we're just going to flip it over. 1/3. So this one is asking, so if I write this in radical form, negative 216 goes on the inside. And it's asking me, since my number in the denominator is 3, my index is 3, it's asking me what number times itself 3 times is negative 216. What's the cubed root of 216? Negative 216. And that answer is negative 6. So that's our final answer there. Okay. Uh-oh. This time they give us radicals, so we have to rewrite them in exponential form first. So let's rewrite this. V, my index is 3. I'm not raising it to any power, so it's 1 times V. There is no index, so it's 2. And I'm not raising it to any power, so it's 1. So now I'm using this exponent rule right here. I'm going to add my exponents together. So I'm going to do V to the 1/3 plus 1/2. But I need a common denominator, and my common denominator between 3 and 2 is 6. So I'm going to multiply this guy by 3. And this guy by 2. So I have V to the 2 over 6 plus 3 over 6. And now I can just add them. V to the 5 over 6. And I want to rewrite it in radical form because that's what it asked me to do. My index is 6, and it's being raised to the 5th power. And that's our answer. Okay, so we have 2 more left. All right, I have to, actually I don't have to rationalize the denominator. Let's not do that because that's going to be really difficult. So we're going to rewrite these both as exponential form. For if there's no exponent, the exponent is 1 divided by 4 to the index is 3, 1/3 power. So now we're using our second exponent rule. We are going to subtract the exponents. So this is now 4 to the 1 minus 1/3. Okay. 1 minus 1/3, well, I can make this into a fraction. 1 over 1. My common denominator is 3. So this is now 4 to the 3 over 3 minus 1 over 3, which is 4 to the 2 over 3. Which, as a radical, looks like this. 4 squared, index of 3. This is 16, which I can simplify even more. This is 2 times 8. 8 is 2 cubed. Okay, so I can take out a 2. So again, this one is 2 cubed root of 2. I ran out of room. I should have wrote smaller, but I didn't. Oh well. Okay. This one, x to the 10 divided by 4, which equals, I'm going to get another fraction. It's going to be x to the 5 over 2. So if I rewrite that as a radical, square root of x to the 5th, because my index is 2, I can take 2 goes into 5 twice with 1 left over. And that's it. Okay? All right. That's it for this lesson.